So for this example, we want to solve. If you take a look at what we have on this one, it will kind of explain the idea behind what logarithms do for us. 3 to what power is equal to 7? Well, if you start plugging in some numbers and kind of just do trial and error, 3 to the first power is 3, and that's too small. We want it to equal 7. 3 to the second power, that's 9. That's too big. So looking at this and inspecting it, I can see that our answer is going to need to be something between 1 and 2. So how do we figure out what that is? Well, to do that, you need to have a process, a mathematical process to do that, and that's what logarithms do. They allow us to find solutions to exponential equations that are not nice, easy answers. The process for doing that, we want to get the base and the exponent all by themselves on one side of the equal sign. If I look at this one, the exponent is x. Directly below and to the left is the 3, that's the base. So the base and the exponent, they are all by themselves already on the left-hand side. Once you do that step, or if that step's already in that form like this one is, then what we want to do is we want to use one of our formulas to go through and solve. One of the formulas we had used earlier, let me not use 3 for the base, let me just do the formula like they do in the book with a base of b. In the book, the formula says if you have log with a particular base and you're taking the log of an exponent with that same base, so the base of the log and the base of the exponent are the same, then both of the bases and the log, all of this stuff right here, those cancel out and they just give us an answer of the exponent. So I'm going to use that to solve this equation. I have 3 raised to the x power. That's like b raised to the x power. So what I need to have in front of that is log base 3. The base already has, or the exponent already has a base of 3 here. I need to have log base 3 in front of that so that the base of the log and the base of the exponent match. So let me rewrite what we have here, but I'm just going to spread this out a little bit. Leave a little space in front of each one. And what I'm going to do on both sides of the equal sign is I am going to do a log base 3. Logs are operations, so you can do the same operation on both sides of the equal sign, that's fine. So I'm going to take log base 3 on both sides of the equal sign. And now if you look at this left side, I do have log base 3 of 3 to the x, just like this property. And now I can take the log base 3 and the 3 that is the base of the exponent, use this property and they cancel out. We were supposed to solve this. And to solve this, we needed to get x was equal to something. And now I know what x is equal to. It is log base 3 of 7. That's the exact answer, but our book does want us to round this off to a couple decimal places. So we're going to throw this into our calculator. If you are able to write in 3 for the base of your log, you can type this in directly. Otherwise, we need to use the change of base formula. So using the change of base formula, changing these both into log base 10. There's no base written in there, so this is log base 10. If I type into my calculator log of 7 divided by log of 3, that will give me the answer to log base 3 of 7. When I do type that in, I'll do that horizontally, so it's going to look like this. So let me do that. So we're going to do log of 7 divided by log of 3. And then we'll round that off to 2 decimal places. So that is approximately equal to 1.77. And that's our final answer on that one. As you go through and do these problems, take your final answer, throw that into the calculator, round that off to a couple decimal places. If you wanted to, you can check your work on this by plugging these back in. Remember we said at the beginning we had 3 to the x power is equal to 7. 3 to the first power was too small. 3 to the second power, that was too big, so we knew the answer was going to be between 1 and 2, so this does make sense for an answer. But if you want to see if this is correct, we can take that 1.77 and plug that in and see what we get. This answer here, 1.77, was rounded off a little bit. So when I hit the enter button here, I should get something close to 7, but it won't be exactly equal to 7. The only way I could get the exact answer is if I used log base 3 of 7. That's actually the exact answer. This is rounded a little bit. So this should be very close to 7, but not quite equal to 7 because we did round that off a little bit. When you go through and you're solving these exponential equations, you do not need to show the check to your work. You can check it if you want, but it's optional. There isn't anything in here that would have introduced an extraneous solution. So when you go through and do your calculation, you don't need to check your work at the end. You can if you want to. It's optional. All right, for this example, we have e raised to the 2x plus 1 power is equal to 8. You want to get the base and the exponent isolated, and just like the last problem, all we have are the base and the exponent on the left side. So for these first couple of problems, that's been done for us already. Now I am ready to do a log on both sides. Just let me rewrite this with a little bit of space in front. And then I'm going to put a log in front of both of those. The base of our exponent is e, so what we need to do on both sides in order for us to use this formula, this property, is we need to have log base e in front of both. I am going to write this as log base e on both sides right now, just to emphasize that the base of the log and the base of our exponent match and give us a visual on that. But remember what log base e is. It's really natural log. So if you want, you could just do natural log on both sides. So again, this log base e of e to a power, base of the log and the base of the exponent match, so they cancel, just giving us the exponent, which is a 2x plus 1 this time. And we have log base e of 8, which is natural log. So let me write that as natural log this time, since we're done with this step, or you maybe would benefit from having that visual there. We're solving. We're trying to get the x all by itself, and we're a little closer than where we started. Now I just need to move a few things over to the other side, and we should be with our solution. So if you have 2x plus 1, to solve that, you're going to subtract 1 on both sides. That would give me 2x is equal to, a lot of times people will put a regular number in front of the log and write it as -1 plus the natural log of 8, rather than the natural log of 8 minus 1, because then people are tempted to subtract them. Let me write this up over here for a second, just as kind of a side note. So if I wrote the right side this way, natural log of 8 minus 1, we do the operation of natural log before we do subtraction. So this is not equal to the natural log of 7. You can't do that step. Natural log of 8 minus 1 is as good as that gets. But to make sure people don't make this mistake and accidentally do that subtraction, because it looks like maybe we could, people will often put the -1 in front. Then you're not tempted to do that step. We are solving for x here, so we do have one more step. We do need to divide everything on both sides by 2. That would give me x is equal to a -1 plus the natural log of 8, all of that over 2. That's the exact answer. Can't really simplify that anymore, but we are going to throw this into our calculator, and we are going to come up with our decimal rounded to 2 decimal places. When I do this division, I do need to put the top in parentheses. I could put the bottom in parentheses too, but it's just a single value, so that's not really necessary for the bottom part. So top in parentheses, and then divided by 2 in the bottom. So about 0.54 is what we end up with for an answer on this one. If you wanted to check your work, take that, plug that back in the original, and you should get something close to 8. Again, this is rounded, so it wouldn't be exact.